Hello everyone, this is Danish Kapoor with PMT. In this section of the video, we'll be creating a custom mill from a solid file. The one that we'll be creating today is an insert drill. So let's get started. Alright, so the first thing we need to do is we need to import our geometry. So for me, I have saved it under the tool folder that I created. Could be an STL, STP, whatever you have downloaded from the manufacturer's website directly, so you can import that. Alright, so that's the tool that I have imported. It's in black, so let's change some of the properties first. I'll create a layer so I can put it on a different layer just for the housekeeping purposes. I like to keep things separate. Alright, that's the layer I have created. Let's select the tool. So that's my tool, and let's change the color first. I don't like the absolute black color. Something grayish would be okay just for me to see. Alright, and I will save it on a different layer that I just created, the solid layer. Alright, so the first thing I want to do is I want to align it vertically in the XY plane. So let's go to the top view, and we want to align it vertically. So the first thing we need to do is basically rotate it 90 degrees along the z-axis. Let's do that. Select my tool and then right click on your mouse button, copy, and I don't want to create a copy of it, I just want to move it, and I want to rotate it 90 degrees, and I don't want to use the origin. I'll select the axes that I want. So for me, I want to rotate it around this axis. Perfect. So now it is aligned vertically the way I want. Alright, so the next thing I want to do is I want to create or extract the geometry for this tool, and for that we can use they call this turning profile feature or turning profile function, right? So let's do that. Before I do that, let's create a new layer. So the geometry that I create is saved on a different layer. I'll say geometry. Alright, click turning profile, and it's asking me to select the part or the faces, so I'm going to select the whole part. Alright, and what type of profile do we want? Does it need to be a front face or a back face? So we need the front face on this side. And do I want to create a geometry or a feature? I want to create a geometry. Profile, does it need to be the bottom or the top? So I'm just going with bottom for now, and then we can translate it later the way we want it, and hit OK. Alright, so now if I hide the solid, we have successfully extracted the 2D profile of our tool. And for basically following all the steps, there is the help page available as well on how to create a geometry for a custom mill, right? So my motive is to keep everything in line with the instructions given by Hexagon, and to kind of show you how you can do it as well. All right, so next is, so there are some pointers that we need to follow. The profile must have a point in the Y0. It can contain arcs and segments, right, starting with X minimum at Y0, right? So we need to translate our profile so that it's aligned correctly with the XY plane, right? So basically move it up in Y, right? And then we need to close this as well. So what I'll do is I'll create an infinite line starting from this point, right? The angle is going to be 0, and then what I'll do is I'll create another line here, right? And then the distance is going to be 0, so a vertical and a horizontal line. All right, and hit cancel. So if I select that. All right, so next I want to kind of trim down the infinite line, so I'll use this trim functionality. Looks like that line did not get created. Let's try that again. Infinite line. Okay, let's see now. Yes, it's created now. Trim. All right, so we have that. Let's take care of that, and then we'll need to trim the line at the bottom as well. Okay, and then you can see it's starting from this point and going all the way. So let's just close this profile again, and then starting from this point, so the angle is going to be 0 again. And now we've used the trim functionality to kind of trim down our 2D geometry for the tool. All right, and then this guy and this guy. All right, so if I select the profile of the tool while holding down the shift key, you can see that's the whole 2D profile of my tool created. Right, so next thing I want to do is I want to translate it in the Y. Now the distance is going to be from this point, kind of the length of this segment. I can create 2 points, right? So easier way would be just to select this segment and note down the length. So the length is 18 point, I'll just note it down on my notepad. So 18.696317. Okay. All right, so let's select the profile of the tool and translate it in the Y positive, move it, and select translate from the drop down menu. So the same distance, 18.696317, hit OK. Alright, so now my profile has been moved. The next step is I want to save the cutter profile and the insert profile separately, and that should probably be it. So before we do that, we need to define the point where the cutter differentiates, or the insert differentiates from the shank of the tool, right? And there are a few other steps we need to kind of follow along as well. So let's have a look. So it says define the limit point between the cutter profile and the shank profile. So for them, they have it along here. So for our tool, so I think we can probably use this point, right? So the upper portion will be the shank and the lower portion will be our insert, right? So I'll use this point function. I'll snap a point at exactly the right there. Perfect. All right, let's have a look at the next step. And so yeah, basically if there are any concavities, we need to remove that, and also the fact that the profile must be monotonic in the X and Y. So if it's kind of bending, we can create a straight line. So for our tool, right, so it's already straight, it's already monotonic, so we don't need to create any additional lines for ourselves. Okay, so let's have a look. So we need to create a line to kind of separate between the separate the shank from the insert, right? And then it's asking us to translate the shank profile in the Y, so the starting position is at Y0. All right, let's do that. So the first things first, let's create a line. So use this function, put that point, basically angle is going to be 0. So our line is now created. I'm going to use this trim functionality, and there we go. All right, So just for the sake of basically keeping everything in line, I like to save everything on different layers. All right, so, and we don't need this, we just needed it to kind of get the distance. So I'm gonna remove this profile and also this section as well, we don't need that. All right. All right, makes sense. Okay, I'll just narrow it down. All right, so I'm gonna create a new layer for my shank and for my insert shank, and then one for the insert so I don't get confused. All right, so the first thing is let's select this profile. So to select the first segment and the last segment, and now while holding down the shift key along with control, we can select any element between these two elements and it will kind of complete the loop for us, right? So this is now my insert profile, and I want to save these lines or segments on my insert layer. All right, okay, and now let's activate the shank, insert, uncheck or hide the insert layer. All right, now we are just left with the shank. Okay, so the next step is, so we actually also need the distance. Let's actually trim this line that we created. All right, so now we can actually know the distance from this point to the bottom, so we can translate it down. So if I select this segment, the length is 1.300. I'll just note that down. 1.30071. So this will be our cutting length when we are importing the ECT files or the tooling files for our geometries, for the tool geometries. So we need to enter this length. This will be our the cutting length, right? Okay, so we don't need that anymore. Let's get rid of that. And now we need to move the shank profile so it starts at Y0. All right, so let's quickly have a look at the instructions. So it needs this line. All right, makes sense. Perfect. So select this. Okay, so with that selected, I'm going to translate this selected profile down in Y by the same distance. So it's going to be negative 1.30071. All right, so now our shank profile is starting at basically Y0. We don't need this point. Let's get rid of that. All right, so we have successfully completed these steps. Now let's have a look what it's asking us to do. So now it's just down to saving both of the insert and the shank profiles as the tooling geometry files. So let's do that quickly. All right, so let's save the shank first since we already have that in front of us. So hold down the shift key and select the element to complete the chain. All right, now with that selected, let's go to save as. I have already created a tool folder. So now the thing that we need to keep in mind is that we are saving it as a tool geometry file, the ECT, and this is our shank profile. So save our shank. I'll hide the shank and now activate the insert. So basically the shank was on the geometry profile, on the geometry layer. So I think I didn't save the shank to the shank layer, but that's okay. Let's hide the geometry layer, and now we are left with the insert. So let's select this insert profile, and now save as. I'm gonna put it in the same folder. The tooling geometry file, this will be my insert now. Insert and save. And that's pretty much it. That on how you can create the tooling. So next thing is we just import the profiles that we have created, and ESPRIT Edge will automatically create the tool for us. So I'll just show you what we just created. So I'll just add any machine, and it's going to be 3-axis mini mill. All right, that's okay. And on the station, you can use this menu, or you can use the tooling menu here as well, whichever works for you. We are looking for the custom mill option. So on the station, if you want to add an adaptive item, you can select any holder, but I'm just going to create the tool for now. So custom mill. If you already have something saved from your previous work, just make sure you default all before continuing. That kind of removes the previous saved data and defaults everything. All right, I'm happy with the number extension. I don't need to change that right now. Shank, so the type of the shank is a custom shank, right? And the cutting length is going to be the point, the length of the point that differentiates between the insert and the cutter, right? So from Y0 to the point where we dropped that point to kind of differentiate between the insert and the cutter. So that's going to be our cutting length. So that was 1.300071, and we're going to browse for the shank profile. So in our tool, so that's our shank. Click open. So now the shank has been created. Same thing we're going to do for cutter. Let's select the file for the insert, and now the tool is created. So if you see, that's a beautiful looking tool that we have, right? Yeah, it's just going with the default holder. You may want to change that, but the idea was to show you how you can create a custom mill. Yeah, and that falls perfectly in line with the instructions on the Nexus page, right? There we have it. Thank you.